Hey everyone, and welcome back for another deep dive.
Glad to be here.
Today we're tackling a pretty hefty topic, the history of nearly everything.
Nearly everything.
Yeah.
Ambitious.
Right.
We're taking Bill Bryson's A Short History of Nearly Everything as our guide.
It's such a fun book.
It really is.
So where do we even begin with something this massive?
Well, I think the best place to start is at the beginning
Okay.
with the Big Bang.
Okay, so we're going all the way back.
Yeah, as far back as we can go.
I love how Bryson tells the story of Arno Penzias and Robert Wilson.
These two astronomers.
Right. To try to get this annoying hiss out of their antenna.
They were just trying to do their job.
Right, and they ended up stumbling onto...
An echo of the universe's birth.
Whoa.
It's pretty amazing when you think about it.
Yeah, talk about a lucky accident.
They were picking up on cosmic background radiation.
Which is essentially...
The leftover energy from the Big Bang itself.
Wow.
Yeah.
So it's like this faint whisper from the beginning of time that's still out there.
It is.
And the thing is, the universe is still expanding.
Right. And to grasp the sheer scale of that expansion, Bryson points out that 98% of all the matter in the universe was created faster than it takes to pour a cup of coffee.
What?
Yeah, it's mind-boggling.
That's incredible.
It really is.
So it went from this tiny speck to this vast expanse.
100 billion light years across in just 3 minutes.
Just 3 minutes.
It's almost impossible to comprehend.
It's beyond comprehension.
Yeah.
But here's something we can actually relate to.
Okay, tell me.
Remember that static on old TVs?
Oh, yeah.
Well,
yeah.
About 1% of that static is actually leftover radiation from the Big Bang.
That's amazing. I never knew that.
So a little piece of the Big Bang is right there in your living room.
It's a constant reminder that we're connected to this incredible event.
It makes it feel so much more real.
Right. It's not just some abstract theory.
So we've talked about the universe as a whole, but let's zoom in on our own planet and one of the most brilliant minds who helped us understand it.
Isaac Newton.
Yeah, the man, the myth, the legend.
Exactly. Bryson describes him as a genius, but also quite an eccentric character.
Yeah, a bit of a loner.
He was so focused on his work, he'd often forget to eat or sleep.
And there's that famous story about him sticking a needle in his own eye.
Oh, yeah. To study how light works.
Ouch.
Dedication to science, but maybe a little too much dedication.
Yeah, but his work on gravity, that was revolutionary.
It was.
I mean, we take it for granted now, but before Newton, nobody really understood why things fall down.
Exactly. His law of universal gravitation changed everything.
It explained.
Why planets orbit stars, why the moon affects tides,
Right.
why apples fall from trees.
It all suddenly made sense.
Exactly. It provided a framework for understanding how the universe works.
And it also helped us understand our own planet better.
How so?
Well, using Newton's laws, scientists were able to calculate the Earth's weight.
Oh, wow. How much does it weigh?
Almost 6 billion trillion metric tons. That's a lot.
Yeah, that's heavy.
Amazing.
And they also figured out that it's not perfectly round.
Oh, really?
Yeah, it's slightly bulged at the equator because of its spin.
So it's more like a slightly squashed ball.
Yeah, pretty cool, huh?
Yeah, it is.
But there was one big question that puzzled scientists for a long time.
What's that?
The age of the Earth.
Ah, yes. How old is our planet?
Back in the 17th century, there was this Archbishop, James Ussher.
I've heard of him.
He calculated that the Earth was created.
When?
On October 23rd, 4004 BCE.
Specific.
Right.
So he thought the Earth was only about 6,000 years old?
Yeah, based on biblical timelines.
Okay.
And that was widely accepted for a while.
Yeah, but even then, some scientists were skeptical.
They suspected the Earth was much older.
Right. Geologists could see that rock formations had formed over vast periods of time.
Yeah, you can see those layers.
Exactly, but they couldn't precisely measure how long those periods were.
And then along came the discovery of radioactivity.
Ah, that changed everything.
It was a total game changer. It gave us a way to date rocks and eventually the Earth itself.
Talk about a scientific breakthrough.
It was.
Bryson tells the story of Marie and Pierre Curie.
Oh, the Curies.
Who isolated radium and polonium.
And their work was so important.
Right, and then there was Ernest Rutherford.
Right.
Who figured out that these elements decay at a predictable rate.
Right.
Which he called half-life.
And that was the key.
Yeah.
If you know an element's half-life,
right,
you can analyze a rock sample and see how much of the original element is left. And from that, you can calculate how long it's been around.
Like a built-in clock within the rocks themselves.
Exactly. It's amazing.
So in 1956, a scientist named Claire Patterson finally nailed down the Earth's age.
Using this method.
Yeah, he used meteorites.
Start.
And the result, the Earth is 4.55 billion years old.
Wow, that's a lot older than 6,000 years.
Yeah, just a little bit.
Quite a bit.
Quite a bit older.
And that brings us to another scientific giant, Albert Einstein.
Ah, Einstein, a household name.
It's interesting how Bryson describes Einstein's early life.
Yeah.
He wasn't a child prodigy.
Not at all.
He even failed his first college entrance exams.
Really?
Yeah.
You wouldn't expect that from someone who became synonymous with genius?
It's a good reminder that brilliance can blossom at any time.
So what happened?
Well, in 1905, he published a series of groundbreaking papers that completely revolutionized our understanding of the universe.
Talk about a turning point.
It was a pivotal moment in scientific history.
Those papers introduced some pretty mind-bending concepts.
Like the special theory of relativity.
Which basically says that time isn't absolute.
Right. It's relative to your speed and position.
Okay, I'm already getting a headache trying to wrap my head around that.
I know it's a bit tricky, but Bryson uses this great analogy of a train.
Okay.
Imagine a train traveling near the speed of light.
All right.
If you're standing on a platform watching it go by.
Yeah.
The train appears shorter, time seems to slow down inside it, and even the clocks on board tick slower.
Whoa.
But for the people on the train, everything seems perfectly normal.
So their time is different from mine.
Exactly. Time is relative.
Okay, my brain is officially melting.
I know, it's a lot to take in.
But that's what makes it so fascinating.
It really is.
And then there's Einstein's famous equation, E means C.
The one everyone knows.
Which essentially means
mass and energy are interchangeable.
So even a tiny amount of matter contains a huge amount of energy.
That's right. Bryson points out that the energy locked inside you is equivalent to about 30 hydrogen bombs.
30 hydrogen bombs.
Yeah, think about that.
I suddenly feel very powerful.
We all have this incredible potential energy within us.
Wow.
But Einstein wasn't finished there.
He wasn't.
No. He also came up with the general theory of relativity.
Which explains gravity in a whole new way.
Exactly. Instead of thinking of gravity as a force, Einstein showed us that it's actually a warping of space and time.
A warping of space and time.
He used the analogy of a bowling ball on a rubber sheet. The bowling ball represents a massive object like the sun. And it warps the sheet, which represents space-time.
Got it.
Smaller objects like planets then follow the curves created by this warp.
So we're not actually being pulled down by the Earth's gravity.
We're following the curve in space-time created by its mass.
Wow, it's like sliding down a cosmic slide.
It's a pretty elegant concept.
So elegant and so mind-blowing.
But as Bryson points out, Einstein's theories work great for explaining the large-scale universe. But when you zoom in to the tiny world of atoms,
things get a lot weirder.
That's where we enter the realm of quantum theory.
Quantum theory.
Yeah, the realm of the very small, where the rules of classical physics no longer apply.
So things get a little fuzzy down there.
Fuzzy is a good way to put it. It's a completely different way of thinking about reality.
One of the key figures in quantum mechanics is Werner Heisenberg.
He
came up with this idea called the uncertainty principle.
The uncertainty principle states that you can never know both the position and the momentum of a particle with perfect accuracy.
So it's not just that our instruments aren't good enough.
It's a fundamental limit to what we can know about the subatomic world.
It's like the very act of observing a particle changes its behavior.
Exactly.
So instead of this nice, neat, deterministic world of classical physics,
quantum mechanics is all about probabilities and possibilities.
It's like the universe is playing dice with reality.
In a way, it is.
Okay, so we've gone from the vastness of the universe to the tiniest particles imaginable.
Yeah, it's quite a journey.
Now let's bring life into the picture.
Okay.
How did life emerge on this planet?
That's one of the biggest mysteries we're still trying to solve.
I know, and Bryson does a great job of explaining just how unlikely life as we know it really is.
Right. He outlines 4 essential criteria for a habitable planet.
Okay, let's hear them.
First, you need the right distance from a star.
Not too hot, not too cold?
Exactly, the Goldilocks zone.
Then you need a protective atmosphere.
To shield us from harmful radiation and regulate temperature.
And a decent-sized moon.
Right, to stabilize the planet's rotation and prevent wild swings in climate.
And a whole lot of luck.
Oh yeah, definitely a healthy dose of cosmic luck.
Bryson points out that even on Earth, most of it is uninhabitable for us.
True, we're clinging to a tiny sliver of the planet's surface.
Just the right conditions for our kind of life.
It makes you realize how precarious our existence really is.
Yeah, it does.
So, how did life arise from non-living matter?
That's the big question, right?
Bryson uses this analogy of a cake baking itself
Okay, a self-baking cake.
to illustrate how amino acids might have spontaneously assembled into proteins.
Proteins are the building blocks of life.
Exactly, it seems impossible.
Yeah, like magic.
But Bryson points out that self-assembly is actually quite common in nature.
Okay, give me some examples.
Snowflakes form intricate patterns.
Right.
Crystals grow from solutions.
Okay.
Even Saturn's rings are formed by particles arranging themselves in a specific way.
So it's not entirely out of the realm of possibility.
Right, so why couldn't something similar have happened with the molecules that make up life?
It's mind-boggling to think about.
It really is.
So this spontaneous assembly of molecules led to the first self-replicating cells.
What Bryson calls the Big Birth.
The Big Birth, the beginning of life on Earth.
And from that single event, billions of years ago,
All life on Earth has descended.
it's like a giant family tree with all its branches and twigs.
We're all connected.
We're all part of this incredible web of life.
And Bryson highlights this connection by pointing out the amazing similarities in DNA across different species.
Right?
Humans share 50% of their DNA with a banana
With banana. Crazy, right?
and 60% with a fruit fly.
And 90% with a mouse.
So much for human exceptionalism.
It shows how closely related we are to all other life forms.
And scientists have even discovered that they can insert human DNA into fly cells.
And it functions perfectly fine. That's like there's this universal language of life.
Written in the code of DNA.
It's pretty amazing.
It is.
And this interconnectedness of life is beautifully illustrated by Darwin's theory of evolution.
Natural selection, acting over vast periods of time, has shaped the incredible diversity of life we see today.
Exactly. It's a process of constant adaptation and change.
But life on Earth hasn't always been smooth sailing.
There have been catastrophic events, mass extinctions.
Challenges to survival.
Bryson reminds us that Earth can be a dangerous place.
Yeah, he talks about the threat of asteroid impacts.
Like the one that wiped out the dinosaurs 66 million years ago.
You could be having near misses with asteroids all the time without even knowing it.
It's a thought-provoking, isn't it?
And then there are the threats from Earth itself.
Volcanoes, earthquakes.
He brings up the devastating Lisbon earthquake of 1755.
Which leveled the city and killed tens of thousands of people.
And there's the Yellowstone supervolcano.
A massive caldera that's overdue for an eruption.
It could have a devastating impact on a large part of North America.
It's a reminder that we're at the mercy of forces far beyond our control.
So despite all the beauty and wonder,
Yeah.
our existence is pretty fragile,
It is, but life is also incredibly resilient,
adapting and evolving.
finding a way to survive even in the most challenging conditions.
It's a testament to the sheer power of life.
It really is.
Speaking of power and resilience, let's shift our focus to something that covers over 70% of Earth's surface,
What's that?
the oceans.
Ah, yes, the vast and mysterious oceans.
And we often forget that we know more about the surface of the moon than we do about the bottom of our own oceans.
That's true. We've only explored a tiny fraction of their depths.
So much left to discover.
So much.
Ready to dive in.
Let's take the plunge.
Okay, so we're plunging into the depths of the oceans, ready to explore.
And it's amazing how much we still don't know about them. Right? We were just saying.
Yeah, like we've mapped the surface of Mars in more detail than our own seabeds.
It's true. And it really shows how much we've focused on the stars, looking outward.
Yeah.
And maybe haven't given enough attention to this incredible world that's right here on our planet.
So where do we even begin with exploring something so vast and unknown?
Well, Bryson takes us back to the early days of ocean exploration.
Okay.
Back to the 1870s.
The 1870s.
With the HMS Challenger expedition.
I remember reading about that.
Yeah.
They spent over 3 years sailing around the globe collecting data and specimens,
It was an incredible undertaking.
especially with the technology they had back then.
I know they didn't have sonar or submersibles.
So how did they do it?
They were dredging the seafloor,
Dredge?
using nets and ropes, basically feeling their way around in the dark.
Wow.
And yet they managed to collect a huge amount of data.
What kind of things did they find?
They discovered thousands of new species. They mapped vast areas of the ocean floor.
It's amazing what they accomplished.
And their findings filled 50 volumes.
50 volumes.
That's a lot of data.
That's incredible.
Yeah, a true testament to their dedication.
Okay, so from the 1870s, let's jump ahead a bit,
Okay?
to the 1930s
The 1930s.
with William Beebe and Otis Barton.
Ah, yes, the bathysphere pioneers.
They designed this tiny submersible,
A steel ball, really just big enough for two people,
and they were lowered into the deepest parts of the ocean.
where no one had ever been before.
That must have been terrifying.
Oh, I can only imagine crammed into this tiny sphere being lowered into darkness.
But they set diving records.
They did, reaching depths of over 900 meters.
And they came back with these amazing stories.
Tales of strange creatures that glowed in the dark.
Bioluminescent life forms never seen before.
It must have felt like exploring another planet.
But it was right here on Earth, hidden beneath the waves.
And even today, with all our advanced technology, we've only explored about 5% of the ocean.
5%.
That's it.
So there's still so much out there to discover.
Who knows what incredible creatures, ecosystems, geological formations are waiting to be found?
It's pretty exciting.
It is.
Okay, so from the vastness of the oceans, let's shift gears to something much smaller but equally important.
What's that?
Bacteria.
Oh, bacteria, the unsung heroes of life on Earth.
Bryson devotes a whole section to these tiny organisms.
They're easy to overlook because they're microscopic.
But they're everywhere.
Everywhere, and they make up the vast majority of the biomass on Earth.
Bryson reminds us that we're covered in bacteria inside and out.
Trillions of them.
And most of them are beneficial.
That's right. They help us digest food, break down waste, play a role in our immune systems.
And they do so much more than that.
They recycle nutrients, purify water, help plants absorb nitrogen from the air.
They're like the tiny engines that keep the whole planet running.
It's amazing how much we rely on these little guys.
And they're incredibly resilient.
Oh, yeah. They can survive in extreme environments, from boiling hot springs to freezing glaciers.
To radioactive waste gums.
You name it, bacteria can probably handle it.
And they reproduce like crazy.
Bryson calculated that if a single bacterium could reproduce unchecked, it would outnumber all the protons in the universe in just 2 days.
2 days.
That's some serious multiplication.
It is. But luckily, there are natural checks and balances in place.
Otherwise, we'd be swimming in bacteria.
Okay, so we've got these tiny but mighty bacteria, the vast and mysterious oceans, the interconnectedness of life through DNA.
It all comes back to this incredible journey that life on Earth has taken over billions of years.
From that first spark of life to the diversity of species we see today, it's a pretty amazing story.
A story of resilience, adaptation, and the constant interplay between chance and necessity.
Bryson really brings all these threads together from the Big Bang to the evolution of humans.
He paints this grand cosmic picture and shows how we're all part of it.
And he leaves us with this sense of wonder and curiosity.
Encouraging us to keep exploring, keep asking questions, and never lose that sense of awe.
A short history of nearly everything is a great reminder that learning is a lifelong adventure.
It really is. There's always more to discover, from the depths of the ocean to the workings of our own minds.
Well said.
So keep those brains buzzing, keep reading, keep questioning, and never stop exploring.
And that's a wrap on our deep dive into Bill Bryson's A Short History of Nearly Everything.
Thanks for joining us.
We'll be back soon with another fascinating topic to explore.
Until then, stay curious.